All right, in this video segment, we're going to be talking about ESCs. So here I have a bag full of different ESCs. I'm going to kind of pull a bunch of these out. Okay, what is all this? What is all this stuff, right? Okay, but many of you have probably seen an ESC at some type, perhaps at this point in the drone program, whether it was with when you're flying the Aeroscout, the intro labs, or in the other plane class where we built a plane, you used an ESC. ESC stands for Electronic Speed Controller. Okay, so here's an example of an ESC. All right, we have our three leads on this side, a red and black on this side, and then this smaller lead that comes off here and has a plug on the end of it. Okay, a lot of ESCs look like that, especially the ones for planes. Okay, and I have a couple other ones here. This is a good example right here, a one that might be found on a modern racing quadcopter perhaps, and it has a bunch of soldering points on it. Okay, so all these little silver points here, a main lead here where the battery would plug into, and all the motors would be attached here to the ESC. Okay. Let's switch over to the dot cam here, and we'll get a closer look at these ESCs. All right, so the first one I showed you guys a little bit earlier looked like this. Okay. So we have our three wires out here. Okay, these go to the motor. Okay, we have our lead with a plug right here. Now this wire's been depinned. Don't worry about too much about that. But this is a plug here that would be plugged into something where you get the signal, how fast the motor's supposed to go. Whether it's a receiver or a flight controller would be plugged in here, and that would tell the ESC how fast you're supposed to spin that motor that's over here, right? And the power for the motor and for the system would be attached to these two leads here, the power and ground. Okay, often they'll have a plug on them. Sometimes they won't, depends on what you're going to do with it. But if you had a plug on there, you'd have your battery, okay, and you'd plug your battery right in there to the ESC. If it was just a single ESC for a plane, for example, and then away you go. Okay. The second example here was this one. Okay, let's get a little bit closer for this guy. All right. And so we see we have this power lead right here. We plug the battery in here to plug in and power up. And then this ESC is actually what's called a 4-in-1 ESC. So it's kind of like it has four of these, right, all combined into one circuit board. So boom, there we go, and we have this. Okay. Now, different designs and things like that. This is much more compact than the four of those other ones. The other ones are pretty cheap and expensive ones, so they're pretty bulky. This is a little more compact. And we have, you can kind of see here on the edge, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 sets of pads there, and each set of three would go to one motor. So motor here, motor here, motor there, motor there. There's our quadcopter, right? So this is just integrating all four of those components into one component here. Okay. Let's go over to the slides for a second. All right, so here we have another kind of diagram here of an ESC. We see these blue leads go to the motor here. The black one and the red one come from the power source, typically a battery or other type of power source. And this single lead here is where the signal is received, and the BEC can supply power here. We'll talk about BECs in a second. But basically, that's a typical single ESC. You have multiple of those in a 4-in-1 ESC, and if you have a plane with multiple motors, you might have multiple single ESCs on your plane as they go to the different motors. Again, ESC stands for Electronic Speed Controller, okay? And they control brushless motors, which is basically the motor we use on pretty much every drone that you see has a brushless motor. These ESCs control the speed and direction of the brushless motors, as well as things like their torque and things like that. Okay. The BEC, this is another little circuit we find in a lot of ESCs. Not every ESC, but a lot of them have a BEC. And a BEC is basically a voltage regulator. So when we plug our battery in, let's take this one for example that has a plug. We'll go back over to the dot cam for a second. Okay, take this one here that has a plug on it, right? So this would be a typical ESC, sorry, for a plane. We're going to plug our battery in. This goes to the motor, right? The motor's powered, okay, but we need a way to power our receiver. And our receiver needs a way to power the servos that are plugged into it. We talked about those with the receivers earlier, okay? This little lead here, it's got three wires, okay? We have a brown, red, and yellow, okay? The darkest color wire, brown and red, or sometimes it's black and red, will be the power and ground, okay? And then the yellow or white wire, lightest color wire, will be the signal. So this plug functions in two ways. We have the signal that comes from the receiver, or whatever is sending the signal to tell the motor how fast to go, comes from that device into the ESC and says, motor, spin this fast. Okay. Well, at the same time, the ESC has a little circuit in it called the voltage regulator, which takes the voltage of the battery, whatever it is, 3-cell, 4-cell, whatever, okay, it's plugged in there, and it takes that voltage and it regulates it down. So instead of being 12 volts or something like that for a 3-cell battery, it regulates it down to 5 volts. 5 volts is a super common voltage that receivers like to have. Okay, so if we grab a receiver, let's say my little RC plane here, pull this up a little bit more, and my battery, my ESC, and here's my little receiver, right? So this would plug in here. Okay, doesn't matter which spot I plug it into for right now, but let's say it's plugged in like that. Okay, and again, so the signal comes from my transmitter, my controller, right? Comes to the receiver. The receiver says, hey motor, spin this fast. That's going along that signal line, that lightest color wire. Okay, where the power to power the receiver doesn't have a battery, right? There's no battery inside of here. The power to power the receiver comes from this battery through the ESC, where it gets regulated or reduced in this case down to 5 volts, and the receiver says, hey, I like 5 volts, that's great. If you put the full 12 volts into the receiver, it'd probably fry the receiver, so we can't do that. Right, so the BEC, or battery eliminator circuit, brings that voltage down from the battery voltage, whatever it is, to a voltage that the receiver and our servos will also like. Okay, because you'd plug your servos into here as well, your ailerons, elevator, whatever it is. Okay, so BEC is kind of a weird name. You say, what, battery eliminator circuit, right? What does that mean? Okay, in the days of RC planes that had gas engines and stuff like that, which still are out there but not as common, in the days of those planes, you would have a plane that had a battery just to power the receiver, right? A little small little battery to power the receiver, and then the motor on the plane was gas, so we didn't need an ESC at all. Okay. Once brushless motors got to be powerful enough to work correctly and everything and power the planes, they said, hey, we need an ESC on our plane to power our electric motor on our plane. And the electric motor needs a battery that's enough to power it, right? So we have our electric motor here, and then we had a little teeny, let's use this for example, little teeny receiver battery, okay? And they say, hey, well, if this battery is for our motor and this battery is for our receiver, can't we just like do some voltage regulating or somehow get the voltage power from this battery to power both our motor and our receiver? Can't we do that? And they could, and that's the result there is a battery eliminator circuit. So we eliminated this battery, and now this battery powers the whole system instead of just powering the motor and having a separate battery for the receiver and servos. So hopefully that makes sense. So remember, a battery eliminator circuit, BEC, is a voltage regulator. That's what it is. It just has a funny name in the world of RC airplanes. Okay. All right, let's go back over to the slides here. So we have our ESC there, and we have those basically different parts. We'll talk about motors in the next set of video clips here, but we have our motor coming off these blue wires here, right? And our power coming from the battery, and then we have our signal power in the BEC in that small set of wires with the plug. Okay. Here's another photograph of other types of ESCs. These are much more popular nowadays. They're more advanced. You can do more cool things with them in some cases. Okay, BL Heli ESCs. There are BL Heli S ESCs and BL Heli 32 ESCs. There's also another type called AMD 32. No, it's not AMD, sorry, AM32, I believe, is another type of ESC. These are all referring to the type of firmware or kind of like the code that's running on the ESC, and that allows you to interact with the ESCs in different ways, to set them up to do different things, different settings. You can do it all through the computer, which is really nice, to have that interface as opposed to having to try to decipher a bunch of little blinking LEDs or beeping sounds from the ESC and motor. So this is just want to make you aware this is out there. We are going to use BL Heli S ESCs with Blue Jay firmware when we build our quadcopters. So that's one thing that you can look forward to, I guess, or learn more about, and we'll learn some more as we get closer to that. Okay. Over here you can interact with them via a computing device like a computer, right? and they have a feature called pass-through, which often works great. You can kind of get to the ESC's settings through your drone. When you plug your drone into your computer, you go through the drone's flight controller or onboard computer to talk to the ESCs and set their settings and things like that. One thing that's really nice about BLHeli and other types of BLHeli ESCs is you can change the motor direction without having to physically resolder stuff. So with these old-fashioned types of ESCs, okay, if we look here, with these types, if I wanted to change the motor direction, like it was spinning the wrong way for the propeller I had, I'd have to physically take the 3 wires and kind of switch 2 of them and plug them back in. And that would change the motor direction. Now that's not that hard, right? If you have little connectors like this, but if everything's soldered, like on this kind of ESC, where all the wires are soldered directly to the ESC, then it's kind of a pain. You go, oh, my motor's spinning the wrong way. I got to bust out the soldering iron and resolder the wires and switch them around. That's kind of annoying. But with the BLHeli ESCs, you don't have to do that. You can just change it in the software and say, spin this motor the other way. And that's pretty nice. Okay. So you'll see those out there in the wild, I guess. When the world of drones, you'll see these different names: BLHeli S, BLHeli 32, Blue Jay, AM32. Those are all more advanced ESCs that have some type of interface with a computer and more configuration abilities than the old kind of old-fashioned ESCs. Here are some screenshots of the tools used to configure those ESCs, like BLHeli. BLHeli Suite seen here at the left. Okay, this is basically a piece of computer software used to change all these settings. It looks pretty complicated and it doesn't look super user-friendly. That's okay. It's still better in some ways than trying to swap the soldering joints around and doing things like that. You get some better performance out of your ESCs once you learn your way around this software. We have BLHeli Suite 32, a little more polished there. Or sorry, this is BLHeli Configurator. Sorry about that. And we have BLHeli 32 Suite, which looks similar to BLHeli Suite, right? You can change the settings in there. And then there's a newer kid on the block, I guess you could say, called the ESC Configurator, which is a web-based tool. I'll show you guys in a specific video of me using this tool, but for now, we'll just be aware that these are out there. We will use the ESC Configurator tool, which is a Chrome-based like web application, in class when we configure our ESCs on our quadcopters. So you can look forward to using that. Okay. And there's a demonstration that's going to be in the other video. So hopefully this helps as far as ESCs go, understand them a little bit more. Again, electronic speed controllers, they're present in lots of different items that you might be familiar with, like your electric skateboard or your scooter or your e-bike or whatever. Motors have to have some kind of controller to tell them how fast to go, and so ESCs are a lot of places in our modern electrified world. So, all right, we'll see you in the next little video.